Welcome to my presentation. In this presentation, we shall look at an example to see how we can solve eigenvalue and eigenvector. So in this example, let us say we have a matrix A given to us as 1, 4, 2, and 3. Those are the elements of the matrix. And a vector X is given to us, and the components of those are 2 and -1. We want to find the eigenvalue of matrix A corresponding to vector X. Okay, so as a first step, we will recall the equation of eigenvalue and eigenvector. We know the standard equation is AX is equal to lambda X, where lambda is the eigenvalue and X's on either side of the equation are the eigenvectors. If we were to take the left hand side of the equation AX, and if we were to expand it out, we will find that the eigenvalue is embedded in the solution. So we will show you how to identify that. So A is a matrix. Let's write that thing down: 1, 4, 2, and 3, and then X is another matrix: 2 and -1. And if we were to expand this out, we should be able to do the math with respect to multiplication of these two matrices. First, let us identify whether the multiplication is possible. Matrix A is a 2 by 2 matrix. It has 2 rows and 2 columns, and the matrix X is 2 rows and 1 column. Since the columns is equal to the rows, we can come back and then say the multiplication is possible, and then the final matrix is going to be a 2 by 1 matrix. And the way the multiplication is performed is we take the first row of the first matrix and then multiply to the first column of the second matrix, and then we repeat the process for the second row as well. So let us get that started. 1 times 2 plus 4 times -1, that would be the first element of the product matrix. Then we take the second row and repeat the process. So it is going to be 2 times 2 plus 3 times -1. So we will simplify this math here, and when we simplify, this is what we're going to get. 1 times 2 is 2, 4 times -1 is -4. And then 2 times 2 is 4, 3 times -1 is -3. So therefore, when we simplify this, this is going to be 2 minus 4 is -2, 4 minus 3 is +1. So we can write this one as -1. I'm going to pull out -1 as common, and then we're going to write whatever is left inside this set of matrix here, and that is going to be, if I pull out -1 from -2, I'm left with 2, and if I pull out -1 from 1, I have -1. So if I were to look back at the original expression, the value of X is 2 and -1, and this is our given vector X, isn't it? That is our given vector X. And we can also observe in here that this -1 is the eigenvalue, which is represented by lambda, and that is -1. We have shown that in this solution that lambda is embedded in the solution, and when we pulled it out as common, we were able to see that, and this lambda is what is called the eigenvalue of the given matrix X, given matrix A. Okay, so this is the way we want to be able to find the eigenvalue and the corresponding eigenvectors for a given problem. In my next presentation, we shall look at some more examples related to eigenvalue and eigenvectors.